yes, it is me again, Mrs. Tremblay, recording math lessons from my basement live in St. Clair Shores. It is time to learn how to solve proportions. So in section 3.3, we learned how to create proportions from verbal situations and determine if they were proportional or not, and you were given all four numbers. Now what I'm going to do is I'm going to give you a proportional relationship. So I'm going to give you two equivalent ratios, and there's going to be one value missing, and you're going to have to figure out what that value is. And for this one, there are actually three methods. Again, I'm going to probably end up focusing on just one of those methods with you, but I always want to expose you to ways to do things quickly and efficiently in your mind, like the mental math way as well. So I don't want to exclude those. All right, so again, our goal is for me to give you a proportion that looks like this with one value missing, and for you to be able to tell me what that value is, no matter what the situation. Some of them I like to call Captain Obvious, and some of them are not so obvious, and you need to have a little strategy bank. So I have 2/3 equals what number over 12? So basically what I'm asking you is, what value would I need to replace n with to make those equivalent to one another? The first one says use mental math. So in using mental math, I would say to myself, well, okay, 3 times 4 is 12. So if I multiply the top by the same number, because that's how you create equivalent fractions, 2 times 4 would be 8, so n equals 8. So in mental math, if it's a multiplication fact, generally, that most people know up to their 12s, then go ahead and apply that, and you can find your answer that way. And you can always check it using the cross products property. 2 times 12 is 24, 3 times 8 is 24. Yeah, it's right. Okay, next one is to use the multiplication property of equality. So that's fancy for when the variable is being divided by something, you learn that to find out what it is, you multiply each side of the equation by whatever it's being divided by, aka the multiplication property of equality. So this just looks like a one-step equation, right? So if you saw it set up like this, n's in the numerator spots being divided by 12, you could just say, okay, well, to find out what n is, I can divide both sides by 12. Multiply both sides by 12. Those would cross cancel, and n would equal 12 times 2 is 24, and 24 divided by 3 is 8. Notice, we still got n as 8 for the same exact proportion, and we should. Another one, and this is the one that I'm going to kind of push for, because honestly I think it takes the least amount of time and it works for every single one, not just the Captain Obvious ones like 3 times 4, because you're going to have some that are not quite as simple as this. Alright, so you learn that when relationships are proportional, their cross products are the same. Right? I'm going to say that one more time. You learn that when relationships are proportional, their cross products equal each other. Okay? So what that means is, that means that 3 times n, because there's an equal sign here, equals whatever 2 times 12 is. So 3 times n equals whatever 2 times 12 is. So all you're doing is setting up a one-step equation from this. I'm going to say it one more time. The product of this equals the product of that. So I'm just going to make an equation. 3 times n equals 2 times 12. And once you solve that, it's just a multiplication equation. You would divide both sides by 3. We get n is 8. And the other two ways showed us also that yes, n is 8. It works every single time. So this cross products property, that's the one I'm going to focus on. But the other ways work well when some of them are obvious, like 3 times what is 12. But if you look at our first example here, 10 times what is 15 isn't the easiest thing to figure out in our head, is it? Right? So that's where I would say, just go to the cross products property. So to use this property, we're saying that whatever 10 times x is, that 12 times 15 equals the same thing. So to set my equation up, I'm going to say 10x, because 10 times x is written as 10x, equals, then you just take 12 times 15, and you have 180. I am going to require you to show me the equation that you set up. So don't just type all this in your calculator and do the division and do it all at once. I want to see each step. So this is the one-step equation that we can use to figure out what x is. Now all I have to do to solve it is divide both sides by 10. So all you're going to do now is take 180 divided by 10, and we get x is 18. So that means that 12/10 is equivalent to 18/15. If you wanted to make sure that you were right, take 10 times 18, that's 180, and we already determined that 12 times 15 is 180. So you can check every single one to make sure that you're right, which is great, especially on assessments. All right, take a look at the next one. Okay, I have y over 6 equals 3/4, and I basically want to know, okay, what number over 6 is equivalent to 3 over 4? I don't really know 4 times what is 6, right? I mean, I do, but it's not one of those whole number nice obvious ones. So I'm going to use a cross products property again. And I usually start multiplying the letter first and put the letter on the left. You don't have to. You could say 18 equals 4y, but I usually would go with the letter first and say 4y should equal whatever 18 is. Because there's an equal sign, this product equals this product. So again, we have a little one-step equation here. To figure out the value of y, we're going to divide by 4. And when you take 18 divided by 4, we get 4.5. So that's the value that would make y true. You don't have to then figure out what the fraction would be, because technically you cannot leave a decimal within a fraction, right? But here we're just figuring out what that value would be. I'm not going to make you go further and change it to an equivalent ratio. All right, next. This time p is at the bottom. It's okay. We can still use our cross products property to find out what's missing. So 3 times p, or 3p, should equal whatever 17 times 9 is. When you take 17 times 9, you get 153. So to find out what p is, in case you don't already know, we will divide by 3. And when you do that, 3 goes into 15 5 times, 3 goes into 3 once. We get that p is 51. So that means that 9 over 51 is equivalent to 3/17. And it is. Right, I'm going to fold my paper so I have enough room. You don't need to fold yours. Okay, so maybe you're like, yeah, this is a piece of cake, I love it. And then we get to this one, and you're like, well, what am I supposed to do now? These look different. It's the same exact process here. We're going to use CPP, the cross products property. I'm going to start with the term with the letter. I have 2m times 30. All you're doing is taking remember we're using the distributive property and there was a letter inside and you just multiplied the numbers and kind of brought over the m. This is just saying 30 times 2 times m. 30 times 2 is 60, and times m is 60m. That's it. If you have 2m 30 times, you have 60m. Then take your 18, multiply it by your 5, and you have 90. So in order to figure out what m is, this is just a little one-step equation. All you need to do is divide by 60. So when you take 90 and you divide it by 60, you get 1.5. And you are done. That's what m equals. So when you take 2 times 1.5, that result will give you the number that you need to divide by 5 to get an equivalent to 18/30. That was quite the sentence. Maybe I'll dissect that more in class. Okay, now, ooh, this is a good one. Yeah, this looks way different. It's not too bad. We just talked a little bit about the distributive property, so hopefully that will help. Cross products property says that 40 times 6 is equivalent to 15 times y plus 1. Now here's the deal. I don't want to just take 15 times y. I need to take 15 times that whole amount, right? So when you see that there are 2 terms here, you need to multiply the 15 by both of them. So one way to look at it is 15 times the quantity of y plus 1. You could also individually just multiply and say, well, 15 times y is 15y plus 15 times 1 is 15, and jump right to that step. That would be fine. Either way, you'd still end up distributing. 15 times y is 15y. Bring down the addition. 15 times 1 is 15. You'll still get the same equation. So just remember, this doesn't equal 15y plus 1. You need to multiply 15 by both terms. And then, of course, when you take your 40 and you multiply it by 6, you end up getting 240. I'll write it in both spots, just because I can't help myself. So now this looks a little bit different than the other ones, right? That's because this is a two-step equation. So I'm going to draw my line. I know I told you that the equations were never going to go away. I wasn't lying. I know I joke a lot, but I never would lie to you. All right, so here's 15 that's being added. We need to get rid of that first to get the 15y alone. So I'm going to subtract 15 or add negative 15. And 15y equals, when you take the 240 and you subtract 15, you end up getting 225. We're not done yet because the 15 needs to go away. So that means I need to divide each side by 15. And when you take your 225 and you divide it by your 15, yes, you get 15. That's it. All right, last one like this, and then we'll get into some story time with it. This time there's a subtraction sign. It's no big deal. You can still do your keep, change like you're used to doing whenever you see subtraction. And we're going to use a cross products property. So this time, instead of using parentheses, I'm just going to multiply it one term at a time just to show you the difference. So this here means I want to take 4 times x and 4 times negative 2. So I'm multiplying the 4 by the x, bringing down the addition sign to separate the terms, and taking 4 times negative 2. And then we have our 9 times 6, which gives us our 54. So again, we have a little two-step equation here. We'll draw our line down and solve it like we know how to, like we've been doing on skill packets since 2014. All right, we're going to add our 8, and 4x is left. And when you take 54 and you add 8, you get 62. We're going to divide by 4, and when you take 62 and you divide it by 4, you get 15.5. Alright, so basically when you're trying to figure out one of the missing pieces in a proportion, you can use a cross products property, cross multiply to make a one or two-step equation to find the value of the variable, and you can always plug it back in to figure out if you are correct or not. Alright, turn your page. The last thing I want you to be able to do is to write a proportion and then solve it. So in the other proportions that we wrote, we just had to write a proportion and then we had to see, are they equivalent? Now there's going to be a piece missing. We're still going to use that when we set up our proportions to have the same variable across from one another. I think that's very helpful. Then there are multiple ways to set them up. I'm going to just focus on one way so it's not teaching you a million ways to do the same thing. That could be kind of confusing and make for a super long video. Okay, so number 1 says use a verbal description to set up a proportion. Be sure to match up the variables. Use a letter to represent the unknown amount. So there's going to be some part of this proportion that you don't know. When you're given a proportion to solve, you're usually given 4 things and one of them's missing. So, number 2, we'll solve using one of those 3 methods. The end. Okay, so here's the first scenario. It says a cell phone company charges $5 for 250 text messages. How much does it charge for 300 text messages? So we're missing something here. We take the first rate that's given. It says $5 for 250 messages. So I'm going to set this up as 5 over 250. And I want you to remember that the 5 represents the dollars and the 250 represents the texts. Okay? That's important. All right. Now it says how much does it charge for 300 text messages? It gives you the number 300. Now you have to determine, does it go in the top or in the bottom? 300 is the number of text messages, right? The text messages in your original ratio are on the bottom. You need to put the text messages across from the other text messages. That means we're trying to figure out the cost here. You can pick whatever letter you want. I'm just going to use C for cost. You could use X if you want, because we're always used to using X all the time. That's fine. So right here, this 5 over 250 equals C over 300 is the proportion I can solve to figure out the cost. And we can do the same exact thing here. We can use our cross products property to set up a nice little equation here. So 250 times C is 250C, and when you take 5 times 300, we get 1500. In order to solve this one, all you need to do is divide by 250 because that's what C is being multiplied by. And C equals, when you take your 1500 and you divide it by your 250, you get 6. Now, what does this 6 mean? This means that's the cost. So I'm going to put a $sign here. So it costs $6 to send 300 text messages if it costs $5 for 250. All right, let's move on to the next one. There are 180 red lockers in the school. I know there's not. It's just a made-up situation. I'm sorry. There's 180 red lockers in the school. There are 3 red lockers for every 5 blue lockers. How many lockers are in the school? Okay. This one's a little bit trickier because I'm not asking you for specifically blue. I'm asking you how many lockers are in the school. So there's going to be 2 parts to this. But the first part is to set up a proportion and figure out what's missing. So take a look. There are 180 red lockers in the school. It doesn't tell us how many blue there are, right? And there are 3 red lockers for every 5 blue lockers. So I know this 3 red per 5 blue can set me up in my first little ratio here. So I'm going to write 3 over 5 representing red over blue. Okay? Now, the beginning tells me that there are 180 red lockers. Okay? So this top number is red. I'm going to put 180 up here because it represents red. They don't tell us how many blue ones, do they? So I'm going to use B for blue. Now the question is how many lockers are in the school. If I know how many blue lockers there are in the school, then I can add that to the red and answer the question. But I have to figure out how many blue lockers there are first, which means I need to solve this proportion. So we're going to take 3 times B, which is 3B, and you're going to take 180 and multiply it by 5, which is 900, and solve that. So in order to solve this, we're going to divide by 3. And B equals, 3 goes into 9, 3 times, 2 zeros left over. There are 300 blue lockers. So the question, how many lockers there are in the school? Well, there's 180 red. There are 300 blue. That means there are 480 lockers total. All right, those 2-part problems are a bear. It's tricky. All right, last one. And here we go. We have tree growth. There's tree number 1, tree number 2, inches, years, and it says there is a proportional relationship between inches and years. Use a proportion to find or to complete the table. So completing the table means find out what H is because that's missing. What's really nice about tables when you're trying to set these up is that all you need to do is that. Yup, this tells me 15 inches in 4 years. H inches in 3 years. Tables are set up beautifully for you. So all we need to do is cross products property. 4 times H is 4H. 15 times 3 is 45. We'll divide by our 4. And when you take 45 and divide it by 4, we get 11.25, and that would be inches. So there was a whole section. That was your 3-4 section, was how to set up proportions from tables. I thought we could do it just like that. Nice and easy. All right, I'll see you tomorrow.